Hello everyone, my name is XibengZhang. I'm from the Department of Electrical Computer and Software Engineering, University of Auckland, New Zealand. The title of the paper I present today is Hybrid Maximum Power Point Tracking Method based on Iterative Learning Control and PNO method. The characteristic of PV panel is affected by the environmental conditions, such as the irradiance and temperature. Maximum power point tracking (MPPT) method is used to control the voltage or current of PV to track the MPP. Tracking the MPP fast and accurately with changes in the solar irradiance and temperatures is the goal of MPP technique. However, conventional methods like PNO and ANC cannot be convergent at MPP, which leads to oscillations on PV output power. And every decision of changing the current, voltage, and duty ratio under the conventional method should wait for at least one sample time to compare with the previous values, which causes dead time. To address this problem, the high-frequency PNO method is used to reduce the dynamic response time without any time delay. It can make the operation point close to the maximum power point, and in this stage, the operation point would oscillate around MPP. So the control errors in this stage is periodic. To eliminate this kind of errors, the iterative learning control is used to eliminate the steady state oscillations and error. The simulation results are shown in this slide. The figures on the left side is showing the dynamic performance under the step change of irradiance. The black curve is a proposed method, and the blue curve is the adaptive step size conventional method. It shows that the proposed method have a good dynamic performance. The figures on the right side of this slide is the long-term performance under the control of a proposed method and conventional method. It shows that the output power of PV under the proposed method has less oscillations and power loss. This slide shows the hardware results. The hardware setup are shown in the figures on the left side of the slides. To controlling a lamp is used to provide the irradiance for the PV panel. Controlling the voltage of the lamp can control the can change the irradiance slowly, and using a board to cover the lamp can change the irradiance fast. The hardware results are as same as those we expected. So this paper proposed a hybrid MPPT method based on ILC and PNO algorithms. High-frequency PNO have a no die time in dynamic response. Comparing with the conventional MPPT method, the operation point can be convergent to MPP in steady state under the control of iterative learning control. Also, in this paper, it is proved that the difference slope between the left and the right side of voltage and current curves can guarantee convergence of proposed ILC and PNO method. This means that the proposed method is suitable for any configuration of PV arrays under any conventional conditions. On this paper, the proposed method in this paper can work with the global MPPT method. As a test of the simulation and hardware test in this paper is all in the uniform uniform insolation conditions, and under the partial shading conditions, the proposed method can be used in the second stage in two-stage method. It can handle the steady state errors and isolations within the power chain threshold in software computing method. That's all.